This is Luigi and data pipelines, this PyData Chicago workshop. If you're here for that, you were in the correct space. If you want to go hear about PyMC3, room over. So feel free to settle in. Since this is a workshop, just wanted to let everybody know we're going to actually do some mob programming, and I will explain what that is midway through the talk. And I'm not going to be talking for an hour and 15 minutes because I don't want to hear myself talk for an hour and 15 minutes. I don't know if, can't imagine you guys do. So what's going to happen, sort of the structure is going to be, I'm going to introduce Luigi, show you some basic concepts. We'll do a little bit of things, and then I'm going to set up a situation, and we're going to think about sort of some data analytics questions we'd like to ask, and then you guys are going to work as a group we're going to split up into groups, and you guys are going to do a group assignment. It's going to be fun. But if you are not in the mood to do a group assignment, feel free just to listen to the talk, and you can wander over that way midway through. I totally understand if that's not your speed, but there's going to be some audience participation required, so I want to give everybody a heads up before I started. So Luigi is a data pipeline and batch processing tool that was developed at Spotify in like 2011, 2012. And has continually been updated since then. But before I talk about how Luigi does things, I wanted to sort of bring in, as part of my job as a data scientist, you need a data pipeline, which is that if you're starting a project, it's going to be hard to onboard new people if you don't have clear documentation how you go from your source data, whether that's production data warehouse to online scraping to what have you not. You need some way to organize your workflow, edit and rerun that workflow, and then collaborate. So people use lots of different tools to build their data pipelines. Make is pretty popular. I'm sure you've all seen shell scripts, readmes and documentations. Who's gotten like a data project where they've been assigned something and they'll get like a readme on how to download and clean the data, and the readme is not up to date and it breaks? Has that happened before? Yeah. This is why I sort of believe in the code over configuration version of data pipelining, which is like, don't document how you build your data pipeline, just have it be able to run somewhere. Drake is another tool that's written in Java. There's all sorts of like AWS and Google Compute like data pipeline tools that are entire that. And then finally Luigi, which is entirely in Python, and we're at PyData, and it makes things nice for a lot of reasons, and I'll explain why. So Luigi is nice because it's entirely in Python, and it produces a graph of dependencies for your data, which is there is basically these external abstractions of tasks and targets that produce a directed graph from your source data to your final analysis, whether that be a model, inputting data into an API, what have you not, you can define it. But that graph, it's super easy to collaborate with because you can just run it on any machine that has the dependencies installed, which is just Luigi and whatever else you need. And also it scales well with whether you're running Hadoop jobs or just running Python scripts locally, working with Postgres or BigQuery or what have you not. There's sort of wrappers around working with those pretty common tasks. So I'm going to go through like the sort of core abstractions at the heart of Luigi, and then we'll start playing around with them. So Luigi is sort of built around this concept that like everything is an atomic file operation, which I'll explain. So I've written stuff like this all the time. I have some code base, and I import these functions: generate features, fit model, and deploy predictions. And I say, if name equals main, run this. Maybe I'll set up a cron job to run this nightly. What happens when fit model breaks or deploy predictions breaks, which things break? It's just a fact of life. And you end up having, stuff breaks, and it breaks all the time. Yeah. It's in that. There we go. Sorry, y'all. So when something breaks, fit model is not defined. I generated that error pretty quickly, but sometimes they're a little bit more complex than that. You'll want to be able to resume at the broken step. So failures are going to happen in both your development and production environments. That's pretty much. So by reducing everything to like an atomic operation on a file, like a single unit of work, we're able to rerun from, okay, we don't have the next step file, but we have the previous step. so let's rerun only that, rather than rerunning from the start of the pipeline all over again, which, especially as your data gets larger or your calculations get more complex, it can be incredibly expensive to like generate your features all over again. Or you've been building out this like dashboard data warehouse, and now that the data warehouse that supplies your dashboard has had like generated weekly reports for like 25 or 30 weeks, and it takes an hour to run each week, let's say. What happens if you need to rebuild each week? So using the idea of like this atomic file or database step allows us to resume from each point. So the way you'd sort of build that in just pure Python, like we have these functions that I wrote again, like generate features, fit model, and deploy predictions, and I'll say, okay, if our features don't exist, generate the features. If the model does not exist, fit the model. And if the predictions date is not today, deploy these predictions. Because they're like new predictions and you want to update them and deploy it into your production environment. So that's nice. You can see as the logic of a data pipeline gets more complex from 3 arbitrary functions that I didn't even write and just made into like an actual like complex graph of many different data sources, many different downstream dependencies. This becomes incredibly hard to maintain. So Luigi, to make our lives easy, introduced the idea of 2 different classes, a task and a target. A task is an atomic unit of work. It takes other tasks and targets and produces other future targets. And a target is like a safe state of data. So a target is like a file that would exist or rows in a database that would exist, what have you not. So here's our first task, and I'm going to go through each one of these lines pretty slowly. So we import Luigi, and then we're going to subclass this Luigi.task thing to write our personal task. So I called it my task, and it imports from Luigi.task. We set up a parameter, which is, so you can use these Luigi.parameter functions. And that's basically so you can get a simple command line operation. And then, good Lord. So then we notice that it requires some other task. So this is basically saying this task, my task, is a downstream dependency of some other task. So if some other task has not been run, we cannot run my task. So when we run Luigi, whether it's on the command line or with the scheduler, it's going to run some other task or make sure that it has been run. Then run, this is actually where we execute. Lord, this is not playing nice with me today. This is actually, can this not freak out on me here? There. So run is actually what the task is doing. So in this case, it's opening the output of the prior task. It's opening its output, which is this is given to you by the self object in Luigi, and this is how you write out to files, which is a little bit weird compared to most Python things. So you open up this self.output, and that's whatever file it's writing to. For databases, it's slightly different. We printed hello world from run, and then we close the file. And then finally, we tell Luigi, we define our output, which is going to return a local target. And then it will save it to temp foo bar such. So this will be whatever our parameter is. This is going to write to the parameterized version of this file. So you can imagine that's one way to keep track of like which parameters you've ran your model for and which ones you haven't, or whatever your workflow is. So we're going to actually, let's go to the command line and actually do this real quick. So did I make a scratch directory? No, let's make a scratch directory. And so import Luigi. So class, my task, Luigi. dot external task. And the reason why this is an external task rather than a standard class is this is the first, there is no dependency of this. It exists as the first step. So this is basically defining that something has happened outside the universe of this particular pipeline that is setting up this one. So it will not, well, the example that we provided had a requires a run and an output. This is just going to have a run and an output. So let's give it a parameter. And give it a default. I'm going to make the default equal to 42, the string. And then let's define the run method. And so in the run, we want to output, we want to grab the file that we're going to be outputting to. So you call self.output. And then you want to open it. And we're going to open it in write mode because we want to write. Then I'm going to print to the file, hello world. This is a Luigi job. If we can actually spell. And then we're going to close the file. And then finally, we'll define a local, define the output, which is defining the target. We're going to want to return a target that this is going to be operating towards. So return Luigi.local target temp foo output dash dot txt and make sure, and we grab the parameter. All right, so really simple Luigi job right there. And so now, actually, let me exit this because you guys aren't going to be able to see this. Let's open up. New thing, we've got our test.py. So could do Python test.py. What do people think is going to happen when I run Python test.py? So it's going to error because you can't call a module object, or did I? But anyways, so you'll want to use the Luigi command line tool to invoke your classes when you start. So the module is test, and the task is my task. And then the param is now like 23. No class test. See, this is why. Did I miswrite this? Let me check against this. I wrote this last night as well, so. Oh, here's the actual one. This is a little bit more interesting. Why are you? Oh, okay, param's not working. Got it. So the parameter was not working, so I'm just going to actually very quickly delete this just to show that this will actually print out to the file. So you can get a sense of how you run a Luigi job, because there's a couple different ways to run it, and that's actually not totally intuitive. So we can run Luigi test my task, and we need to give it this local scheduler flag, because I will pull this up. So when we run it, you notice that I said you can run it you can either run Luigi jobs on both the command line and using the Luigi daemon, which has this nice graphical interface. I'll show both. But when you're working in testing environments, you'll want to use it running the command line. So I forgot to feed it the module flag. So the module is the name of your Python file. Generally the test, so our file name is test. My task is the name of the class I defined, and I said use the local scheduler. No module named test. Okay. Let's not remove it. Let's move it. There we go. Why are you not liking me today? Did I misspell something? Yeah, it might be. I'm trying to figure out why. Well, there's actually one way. See, I actually normally, so when I'm writing these, I know we're going to fix this. Let's look at this. So the way I normally quickly, yeah. Yeah, so I think this should do it. Let me give me a quick. This is just a little quick invocation I quickly do on a lot of how I normally write these because I always forget to run the Luigi command, so I just generally want to write Python just as a force of habit, and it forces it onto using the system Python, which sometimes on AWS machines it gets kind of nasty, so now I should be able to go locals. Oh. Right. Forgot that. Register object is not iterable? Huh. All right, I'm going to switch over to the, in the interest of getting us moving, over to the task that I pre-wrote and does in fact run. But in terms of running Luigi, you can either run it using the local scheduler option, which will run it locally on the command line, or you can run it using the Luigi daemon. So you'll need to start Luigi D background and then run it as such. So you'll need to run Luigi D background to start this. So that you can run by writing. And the nice thing about, okay, yeah, it's already running. That's why it was. If I go to localhost 8082, you actually get this nice visualization of all your possible running tasks, and especially if you're like running this on a server, and there's all sorts of ways of configuring this to run, like submit jobs to like a master server that's running your entire company's processes and such. I think that's like basically Luigi. Sorry that didn't like run right away. I should have double checked that. My bad. So what we're going to do for the rest of the session with our remaining 45 minutes, it's going to spend about 40 minutes, 35 probably, doing a little bit of a mob programming exercise where we're going to think through what sort of questions we want to ask of our data pipeline, and then we're going to split off into groups and build them. So if we go to data.cityofchicago.org, you'll notice one of the first things you'll see is building permits. It's number 4 today. And the city of Chicago has published all these building permits. So what we're going to do is, as a large group, we're going to figure out like 5 questions we're going to want to ask, and then we're going to split into smaller groups. So this is what building permit data looks like. And then what you can see is I've written a Luigi task that does work, and you might want some other ones, that downloads this and writes it to a permits file. Let's delete these. No, not that one. So what you can see here is we go and grab the permits data, save it as a response, write it to the output, and then save it as a local target called permits.csv. And we run basic pipeline. Which? Oh. There you go. Sorry about this looking ugly, but It's not found. Okay. Well, regardless, let's pull up this basic pipeline. So this is this basic external task that will give you the data. So I'll let you all copy this. But what I want to do now is maybe think about what are a few types of questions you'd want to ask of permits data if you were, say, a data analyst for the city of Chicago and you were making a report to the city council. And we'll work on that in insert mode. See, still continually screwing up, writing up commands on my text editor. So what are some questions that you'd want to ask of a data set that contains every building permit issued from 2006 to today? What about, yeah? How many of each type of permit? Any other questions? So the city calls that a contractor. So which contractors are getting permits? Any other questions? What's so can you repeat that? Which are the most expensive permits? Location, and probably want to put that on a map, right? All right. And then let's get one more up here. Oh, so it's only from 2006 that they're tracking permits. What about, we've got which contractors are getting the most permits. We've got location. Yeah, well, which zip code, I was going to say which zip codes are the most, well, so location would just tell you where they are, but like aggregating them into groups, which is slightly different than like plotting all their locations. So which zip codes have the most development? So I'm going to leave these up here, and now we're going to do, who here has done a mob programming session before? So it's like a new concept to most people. All right, mob programming is pretty simple. Form like a group of like 5 to 10 of you, and somebody can pick one laptop and basically switch off whoever's controlling the laptop, but everybody can talk every 3 or 4 minutes. So if everybody could form these groups, because we're going to try and build a pipeline that answers each of these questions now that you've already downloaded the data. So if people could form groups, that'd be great. Maybe your row. And you're also more than welcome, if you don't want to do like the interactive stuff, to go over to the PyMC3 session. That is also okay. Yeah. Oh, yeah, sorry. You can also just go to data. This is the download URL. I'm going to copy this and move this to the bottom. Of course, that doesn't fit. There's the whole URL in one screen.